Hi, y'all. Okay, so let's start off by going back over some of this important vocabulary. In an expression, there is no equal sign. In an equation, there is an equal sign. It kind of even says the word, almost says equal in the word equation. There's a lot of other keywords that you need to know. So let's start with the constant. If you think about constant just in everyday life, it's something that never changes. Like if your mom is constantly asking you to clean your room, she's doing it over and over and over again, right? She's never saying, oh, just leave your room messy. So in math, a constant is a number by itself because that number is never ever going to change. 9 will always be 9, right? It's not going to be any other number. But sometimes you have a term that has a letter attached to it. That is going to vary based on what you plug in for x. If you plug in a 1 for x, that term is 2. If you plug in a 2 for x, that term is 4. So because it varies, we're going to call that letter a variable because it's going to make that term vary. So a constant is a number that does not have a letter attached to it, and then the variable is the letter, and the coefficient is the number attached to the letter. That prefix co means it like goes together, right? Like if you're codependent on somebody, you're depending on them. So coefficient is the number attached to the variable. And then your terms, those are split up with plus or minus signs or an equal sign. So 2x, those are attached together. That's the coefficient and the variable. That's just one term. And then we see this plus sign, so then we know we're getting into another term, and then we see an equal sign, so then we have our last term. So there are 3 terms here. 24 is another constant because that's a number that's never going to change. It's always going to be 24. So let's look at some examples. In this expression, what is the constant? So we're looking to see which one is always going to be that number. This is a term that will vary, right? Because it has an x in it. This is not going to be a constant. This is not going to be a constant. The only one that will always be that number is the number 6. It is constant. No matter what you plug in for x, 6 is always going to be 6. All right, so let's look at some more examples. We have x squared minus 6x minus 10. How many variables are in this expression? Remember, variables is like a letter, right? It's an unknown value. So in this case, our variable or our letter is the letter x. And so there is just one variable here. Sometimes there will be an x and a y. That's 2 different variables. In this case, there's just one letter, which is the letter x. We'll talk a little bit more about the difference in x squared and x. Those aren't like terms, but I'm not going to get into that yet. All right, the next one says, how many terms are there in this expression? Well, if we want to know the number of terms, we are going to look for those plus or minus signs. Those plus or minus signs are going to divide the terms. So I'm going to start here, and I'm going to go all the way until I see the next thing, which is the minus sign. And then I'm going to go until I see the next minus sign. And then I'm going to go until I see the next. Well, then it's just done, right? So in this case, there are 3 terms. Each term is split up by a plus or minus sign. Notice when I circle them, I circled the plus or the minus sign in front of it. That's going to be important when you start talking about the coefficient. That minus sign here is attached to 6, so that makes it a negative 6. This minus sign, we're going to give it to the 10, so that's going to make it a negative 10. I'm going a little bit further than this question asked for, but this one just says, how many terms are there? There are 3. Oh, I should have been writing in the, oh well. Okay, on this one it says, what is the coefficient of the x squared term? So we're looking at that first term. The word coefficient is that number attached to the letter. Well, when I'm looking at this, I don't see a number attached to the letter. And when you don't see a number attached to a letter, that means it is 1. There is 1 x squared. If you don't see a number, we're going to put in the value of 1 there. Oops, I'm scrolled to the wrong part. We'll come back to it in a minute. So since we don't see a number there, that is going to be 1. The coefficient in front of x squared is 1 because there is only 1 x squared there. All right, what is the coefficient of the x term? So if we find the x term here, the number attached to it, or the coefficient, the number attached to the x, is actually a -6. And it's really tempting to say that 6 is the coefficient. But remember when I circled the terms, I circled that sign in front of it for a reason. That is actually a -6, not a +6. So we want to make sure that we include that sign with it. Sorry, I'm just going to go back and fill this in because I didn't do it earlier. Whoops, okay. And then what is the -10 called? Love that they put the -10 and not 10 because it is not positive, right? That sign in front of it is attached to it. The -10 is called a constant because it doesn't have a letter. So it's not going to vary. It's not going to change. It's always going to be -10. So that is our constant. All right, let's go to the next example. In which of the following expressions does the x to the third power term have the coefficient of 1? Coefficient, remember that means the number attached to it. So we're looking for the number attached to it or the number in front of it to be 1. Here, my coefficient is a 2. That's the number attached to it. That's not what it's asking for. It wants a coefficient of 1. Down here, oops, the number attached to it is a 6. Again, that's not going to be it. I can mark both of those out. Now, when I look at the second one, I don't even see the number 1. But because I don't have a number in front of x to the third power, it is understood to be 1. There is 1 x to the third. So that is actually my correct answer. Even though I don't see the number 1, it is understood to be there. All right, let's look at a word problem. The cost to take an Uber includes a one-time pickup fee and then cost per mile that you are driven. The total cost for getting an Uber can be represented by the function C of m equals 4m plus 5, where m represents miles. Describe what the number 4 and 5 represent in the context of this problem. So when we read this first sentence, we see two different costs. It includes a one-time pickup fee. That's our first cost. No matter how far you're going, you have to pay this pickup fee. And it includes the cost per mile. That's our second cost. So we have the one-time pickup fee and the cost per mile. So let's figure out which one of these is which. Okay, the one-time pickup fee, that number is going to be a constant because no matter how far you go, you have to pay that one-time pickup fee. So in this problem, 5 would be our one-time pickup fee. It costs $5 just to pick you up. Whether you're going 2 feet down the road or 2 miles down the road, it's going to cost $5 to pick you up. Now the 4, that's the coefficient attached to the letter. And in this case, our letter means miles. So it costs $4 per mile. So the 4 is going to be the coefficient, and that's going to be the cost per mile. So describe what it means in this context. The 4 would be the cost per mile. It costs $4 per mile, and that is your coefficient. 5 is going to be the constant, and that is your one-time pickup fee. Local Gym is offering this new promotion, an enrollment fee of $1 and a monthly fee of $9.99. Which of the following expressions represents the cost of the gym membership for M months? Okay, so again, we have two things going on here. We have an enrollment fee of $1. That enrollment fee of $1 is always going to be $1. So it is a constant. It is just a number by itself. It doesn't ever change. The enrollment fee never costs $5. It always costs $1. So that is a constant. And then we have a monthly fee of $9.99. That means it costs $9.99 per month. So if you go for just 1 month, it's $9.99. But if you go for 2 months, you're looking at like $19 and something. I don't even know. But when we go to set up this equation, we need to have $9.95 per month and the $1 constant enrollment fee. So this has the $9.99 per month, but it doesn't have the $1 fee. So I'm marking that one out. Here it says $1 per month. I mean, wouldn't that be great if that was real life? But it's not the context of this problem. This says $1 per month plus a $9.99 constant fee. That's not what it's supposed to be. The only correct one here is $9.99 per month. We got to put that variable with it because that's what's varying, that's what's changing based on how many months you attend, plus the $1 enrollment fee. That's that constant amount. All right, so here is some vocab. I'm actually going to come back to this if I don't run out of my time in 15 minutes. Oh, actually, I can do it quickly. We're all right. So we have addition. Another word for adding is sum. And an example of that would be 5 plus 10. I'm going to do subtraction next just because that's how my brain works. Another word for subtraction would be the difference between two values. And an example of that would be -8 minus 6. All right, then I'm going to do multiplication next. Another word for multiplication is the product of some numbers. And then an example of that would be 4 times 3 or 2 times x plus 5. Both of these are multiplication problems. Anytime two numbers are pushed together, they are being multiplied. And then for division, that goes with the quotient. And here is an example of division, 10 divided by 5. All right, let's keep going. So now we're getting into PEMDAS, the order of operations. And I am going to color code this because I think it is very important that you realize this. So I'm going to do PE. Now I am giving the letter M and D the same color, and that's really important, and I'll tell you why in just a second. The same thing with A and S. Now let's talk about what each of these mean. Remember, P stands for parentheses. That is always your first step. E stands for exponents. That is always going to be your second step. M stands for multiply and divide, and these are the same color because multiply and divide are in the same step. You do not always multiply before divide. Those are the same steps, so when you get to that, you work from left to right. Whichever comes first from left to right, you do first. You do not always multiply before you divide. It just depends on whatever comes first. Same thing with addition and subtraction. I put those in the same color because those are the same step. If subtraction comes first when you read it from left to right, you subtract before you add. It's whatever comes first from left to right. So let's look at this example. The first thing we're going to do here is we're going to take care of that parentheses. So I'm going to go ahead and write this out. Oops, I thought I changed the color. I did not. Bye. I'm going to start on my first step, which is blue. So we're going to just take care of the parentheses here. 2 minus 6 is a -4. All right, so I've done parentheses. That was my first step. Now my second step, I'm going to look for exponents. I don't have any, so I'm going to skip exponents, and I'm going to go to the multiply and divide step. I see 15 divided by 3, and I see 3 times -4. I have to work from left to right. I do not multiply before I divide here because here the first thing that happens is division. So I'm going to divide first. 15 divided by 3 is 5. And then I'm going to multiply. So my next step was divide, and then my last step is multiply. So my final answer here would be -20. So again, when I color coded these, that's because there are only 4 different steps, and then within this same color, you do whatever comes first from left to right. Oh, I'm almost out of time, so I probably can't do all of this. Let me see what I want to do next. I'll go ahead and do this one. So we are trying to find the mistake. In the first step, they did the parentheses. 19 minus 7 is 12. That's great. In the second step, they did the exponent. 3 squared is 9. That's great. First and second step look great. In the third step, they went ahead and multiplied 4 times 3 to get 12. Uh-oh. In that next step, that third step, multiply and divide are in the same step together. You have to do whatever comes first from left to right. So division actually comes before multiplication in this problem because as I read from left to right, dividing is first. So you would need to do 12 divided by 4 first, then multiply by 3. That's all the time I have for today. I hope y'all have a great day.